Hello everybody, my name is Josh. Today I'm here to tell you about the Pythagorean Theorem. So pretty much it's this theory about triangles and stuff, how they work. Pythagoras is this guy who was born 570 BC. He died in 495 BC. And yeah, he was about 75 years old. He lived in Italy. He was just chilling there. And then one day, he's messing with his triangles and he notices something. He's like, "Hey, if 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 I give these sides names, let's say this one is A, this one is B, and this long side, it's called C. These sides can be interchangeable. They can be A or B, but nah, this long side, it's always gonna be C. The longest side is always gonna be C, but only on a right triangle. This only applies to a right triangle, alright? So he's chilling here with his right triangles, right? And he's like, oh, wait, I just realized A squared plus B squared equals C squared, which means the square root of A squared plus B squared in parentheses equals C. Alright? And this is crazy, right? Because he's like, oh my gosh, these triangles, this is insane. So he decides to test this out on a triangle, right? So he grabs his favorite little triangle. He knows this side is 3, he knows this side is 4, but he's like, I wonder what this side is, right? So he assigns the sides names, or letters, I guess. So this is A, this is B, this is going to be C. The longest side is always C, remember, okay? But these other two sides can interchange. And also, this can only apply to a right triangle. Alright, we're going to pretend this is a right triangle. And if you don't know this yet, a right triangle is just a triangle that has one angle that is 90 degrees. And that's represented by this little square here. So, he puts this into practice, right? So, and he already knows that this is a right triangle because of trigonometry, which I'll go over in a later video. It's a little more complicated, but for now, you're just going to have to trust me. Alright, so 3 squared plus 4 squared equals C squared. Okay, so 9, which is 3 squared, plus 16, which is 4 squared, equals C squared. So if we add those together, it's 25 equals C squared. And, we're almost there, but we still have this pesky little squared. So what you gotta do is gotta square root it, right? So if we square root on both sides, we get rid of the squared, and we get C equals 5. And if you look up this example, it'll tell you this is a real right triangle that exists. So yeah, this is our answer. So let me give you another example. We have this triangle. It's a right triangle, right? So this side, it's going to be 6. This is going to be 8. Remember, not drawn to scale. And then this is just going to be C because this longest side is always C. And another thing to note, this long side, it's just called the hypotenuse. It just is. I don't know why. Ask Pythagoras. But yeah. So we get 6 squared plus 8 squared equals C squared, right? Or you could write this as square root of 6 squared, square root of 6 squared plus 8 squared equals C, right? So pretty much, square root of 36 plus 64, that's 6 squared and 8 squared, equals C squared. Just equals C, right? So, so square root of 100 equals C, and 100 is 36 plus 64, right? So, that means that 10 equals C. You can look this up again. It is a real right triangle that exists. It works. let's try another one, but slightly different. Okay. So let's try this one. Okay. We have this triangle here. Remember, it has to be a right triangle. And this value, this is going to be x, or let's just call it b. Okay? It can be b or x, or whatever your math teacher tells you to call it. Doesn't really matter. It's just a value. This can be this can be 9, and this is going to be 14. Right? You might be thinking, oh no, what do we do? This is terrible. We, we can't do anything because it's not a squared plus b squared equals c squared. It's all bad, because the hypotenuse, we have it, but we don't have b, right? Well, don't worry, it's all right. All right, we still have 9 squared plus b squared equals 14 squared, right? But this time, we're going to have to do a little bit more difficult math, right? So instead, we have 81 plus b squared equals 196. All right, so if we rearrange that, all right, we subtract 81 on both sides, and then we get b equals 115. And you might be thinking, well what 115 does not have a square root, right? And that's, a little confusing. The example I looked up online is bad, but that's fine. Just b equals square root of 115. If your teacher wants you to put it like that, that's fine. You could also plug it into a calculator, get, however many decimals you want, and you could get b equals, I just put 10.7 here. This is also correct. All right, let's try another example. I will plug it in, or I'll put it in. You guys can try it. So, for this one, we're gonna do this. It's gonna be, the hypotenuse here is gonna be 26. This here is gonna be 24, and this is gonna be x plus 5. You might be thinking, oh no, what do we do here? Well, that's up to you. I'm going to give you a few seconds to pause, answer it, then we will do the question. So 3, 2, 1. Okay, so first you start out like normal, right? So you have 24 squared plus x plus 5 squared equals 26 squared. Right? So if we plug that into our calculator, I don't know what 24 squared is in my head. All right. 576 plus x plus 5, we're just going to leave that as squared, equals 26 squared, which once you plug that into your calculator is 676. So now what you do from here, it's simple. So you just have to subtract 576 from both sides, and you get x plus 5 squared equals 100. Right? And now from here, what you have is the absolute value of x plus 5 equals 100, or equals square root of 100, and this is absolute value because whenever you do the square root or the root of an even number, or the thing, it'd be the same as 100 to the power of 1 over 2. And whenever this number right here is even, then you have to do, it's got to be absolute value, right? So when you have this, you have the absolute value of x plus 5 equals 100, or you could just write x plus 5 equals plus minus 10. So you have to subtract 5 from both sides, right? So x equals negative 15 and x equals 5, right? And technically both of these work, but we like Euclidean geometry. So unfortunately for us, this negative 15 is not going to work. We cannot have a side that is negative 10 in length. That's just, like I said, we like Euclidean geometry. And we just have x equals 5. And we can verify this, right? So 24 squared plus 10 squared, because, if we plug in 5 for x, then we have 5 plus 5 equals 10. So 24 squared plus 10 squared equals, and I'm just going to put c in for 26 because we're assuming we don't know it, so c squared. Alright, so 24 squared, 576 plus 100 equals, actually, you know what, I'm just going to put in 26 because that makes more sense. So that equals 576, but that's already squared. Yeah, so that's fine, because 26 squared. So this plus this, so 576 plus 100 equals 676. So that's correct. We know that is right. This triangle is real. It exists. You can look it up. And yeah, so that's how we do it. Thank you all for watching. If this helped you out, please leave a like, subscribe. If you have any suggestions for tutorials I could give, just comment down below. Disclaimer, I don't know calculus, so I can't help you with that. I will be willing to do a bit of research for videos. Not a whole lot. I'm not gonna research like integrals and stuff. But yeah, if you need any help, just comment down below. I got you. Yeah, and that's all I have for you. Yeah. Goodbye.